So shake it off. I don't have a joke for you today. How do I clear your head without a joke? Did I do what 0 said to 8 in here? Okay, here's a joke. Here's a dumb joke to clear your head. What did the number 0 say to the number 8? What did 0 say to 8? It said, nice belt. I know. It cleared your head. That's all I was after. Okay.
Where do you get these? Years of experience.
I don't remember that. It's a long, long time ago. I did not invent the jokes. I steal other people's jokes because I'm not very funny. So this is r of x equals negative 3x squared minus 5x plus 1. Same directions. Let's graph this thing. Let's use the vertex formula to do it. I don't want to complete the square on this. I bet you don't either. So what does the vertex formula say? It says h, which stands for the first coordinate of the vertex, is equal to negative b over 2a. All right. What's the opposite of b? Positive 5, right? The opposite of negative 5. B is negative 5. The opposite of negative 5 is positive 5. Over 2a. What's a? Negative 3. Don't do that. You make me yawn. And then what's 2 times negative 3 then? So negative 5, 6. It's a fraction. Oh, well, we're going to have to deal with fractions. You can pull the negative out front if you want. How do you get k? So you got to take negative 3 times negative 5, 6 squared minus 5 times negative 5, 6 plus 1. Well, does your calculator care? Calculator don't care. Here's a video. What was it? The badger don't care or something like that? Honey badger, yeah. Long time ago. Yeah. Negative 3. Well, I'm not a comedian, so I'm not going to quit my day job anytime soon to be a comedian. That would be a bad move economically. So just do it like this. Negative 3 times negative 5 divided by 6. My virtual calculator doesn't always register the buttons I push. So negative, and then you square it, right? And then minus 5 times, use the negative button, negative 5 divided by 6. And then plus 1. Take a second to verify it all looks like this. It does. It's all good. I got the negatives. We're good. Okay, you get a decimal popping out, but guess what? Hit the math button. The first thing, the math button is right here, right below the green button. The first thing you see, number 1 is fraction, so just hit enter twice. And you get 37/12. That's not so bad, right? Okay. So don't be afraid to use the calculator when it's particularly messy. Negative 5. Now, don't use it every time, right? Because you don't want, in 10 years, when you have kids coming up to you and asking you, Mommy or Daddy, how do I add 2/3 plus 1/2? You can't pull out your TI 1000 and say, well, here's how you do it. You've got to be able to do it by hand. But when it's this ugly, yeah, do it on the calculator. Who cares? So negative 5, 6, 37/12. Okay, wait a minute. For graphing purposes, wouldn't it be better to get decimals? Yeah. Okay. So 5 divided by 6, I'll stick a negative in front of it in a second, is about the best you can do when you're graphing is one place past the decimal. So 0.8, round it to 0.8 negative, right? Negative 0.8, and then 37/12, 3.08, 3.1, I guess, if we round. Could be worse, right? You could be digging ditches. Could be worse. In a hot day like this, that would be worse. Okay. So negative 0.8, let me make this graph paper a little bit bigger. All right, so negative 0.8, pretty close to negative 1, and then 3.1, so 1, 2, 3, just a hair above 3. So almost horizontally by negative 1, almost up a little bit over 3. What value would you like to plug in that's near negative 0.8 to get another point on the graph? X and then r of x. I'm not going to get too creative here. How about, what do you think? What's a value pretty close to negative 0.8 in this vicinity horizontally? How about, well, negative 1? Yeah, you're right. That is pretty darn close. But it wouldn't be far enough away, right? You wouldn't have enough separation there. Yeah, that'd be pretty close. How about a point over to the right a little bit? Or an x value to the right, 0. How about, yeah. And then I don't need a calculator. What pops out if you plug in 0? What's r of 0? 1. There we go. So it's, by the way, does it open up or down? A is equal to negative 3, so it opens, it's a frowny face. And so that the 0, 1 bears that out because that's below the vertex, isn't it? 0, 1. The symmetry is a little more difficult in this one because of the fraction. So, and here's, you want to go back to looking at the fraction. It'll be easier than the, well, actually, since we're just doing it visually, you could still look at the decimal. So we went from this vertex, we went about 0.8 to the right to get to this one, right? So if you go about the same distance to the left, you'll be at the symmetric point over here somewhere, right? And then connect your dots. I'll do it in red, and you're done. I went a little too wide there, I think. Let me try again. Don't make it look V-shaped. Make it look rounded at the vertex. I don't know where the x-intercepts are. I could find them by setting r of x equal to 0, but I'm going to stop there. Except to say, if you want to write this thing in vertex form or standard form, you can do that because, well, you know the vertex. You got it using the vertex formula. So the generic standard form for r of x in this case is a times x minus h quantity squared plus k. So all you have to do to write it in this form for this particular problem is to fill in a, h, and k. Well, a, that's the same a from the multiplied out form, ax squared plus bx plus c. We know that in this case that's negative 3. And then x minus h, x minus negative 5, 6, that's the same as x plus 5, 6. Quantity squared, so filling in the h, and then plus k. K is 37 twelfths, so plus 37 twelfths. And there's your vertex form of the given function.